method, Regula Falsi method. If f of x is equal to 0 is an algebraic equation having f of a and f of b are opposite in sign. That means the root of this equation lie between interval ab. Now the regular Falsi method, using regular Falsi method, the approximate root of algebraic equation is given by x naught is equal to f of a into f of b minus b into f of a divided by f of b minus f of a. As you know, you learn bisection method in which the similar pattern is applied, but the root is given by x naught is equal to a plus b divided by 2. As we learn, bisection method is a iterative process. Similarly, regular Falsi method is also iterative method. As here x naught lie between the interval ab, as f of a and f of b are opposite in sign. If f of x naught is a 0, then the root of this algebraic equation is x naught. We stop the process. But f of x naught not equal to 0, then the sign of f of x naught may be positive or may be negative. Using the interval ab, as we define ab is a interval having f of a negative, f of b is a positive. Consider this. Now x naught is a value between a and b, that means in interval ab. So f of x naught consider here positive, then we take new interval as a x naught, because for a and x naught the value of function change the sign minus to plus. If x naught is f of x naught is a negative also, then we get the interval x naught b, as the reason is the same for f of x naught, and for x naught and b the function change the sign. As we consider f of x naught is a negative, then we evaluate new interval as x naught b. So new root x1 lie between this interval x naught b. By using this formula, regular Falsi method, we can evaluate x1 as x naught is defined as in interval ab as a into f of b minus b into f of a divided by f of b minus f of a. Similarly, x1 can define in interval x naught b as x naught is a first endpoint. So take first endpoint multiplied by taking value of function for second endpoint, that is f of b. Then take sign minus and reverse the process. Now take second point multiplied by value of function at first endpoint and divided by take f of b, that is value of function at b, minus, as it appears in numerator, we take f of x naught minus f of b minus f of x naught. Now f of x1 we evaluate. If it is a 0, then we stop the process, as x1 is the root of the equation. If it is not 0, then we take new interval. The process is repeated till we get the correct root or correct answer of this algebraic equation. Now as graphically we understand this as a given algebraic equation is a function, so we put it as y is equal to f of x, and in a coordinate system of xy it represent a curve like this. Okay, now as we know, the root of this equation is a point where the curve cut the x-axis. Now we can see here, because this point is a fraction, we take integers value near to this point, as we have value a and value b, two integers value, for which the value at which f of a, as you observe here, is a negative value, as it is lie in the fourth quadrant, and f of b is a positive value, as y in first quadrant is always positive. Now what we did in a bisection method, we find the midpoint of this interval. Okay, now in a regular Falsi method, actually these 2 points on a axis we join on a curve, we join them by a straight line. As we join them, the line cut x-axis at a point, and this point is a x naught, which is calculated by this formula. Now we evaluate f of x naught, as here f of x naught not equal to 0, as it's in negative. So f of x naught is not a root, so we define next interval. As you can observe here, the next interval will be x naught to b, as the length of interval is a short term, as a to b it is a short x naught to b, because f of x naught and f of b are has opposite signs, that means sign of function changes. So next interval will be x naught b, as previous interval was a to b. Now next interval is x naught to b. Similarly, now we join these 2 points f of x naught and f of b again. If we join, it is physically it is difficult, but where it cut the x-axis, the next root is lie there as a x1. Now x1 is a root of given algebraic equation. If f of x1 is a 0 but f of x1 is not equal to 0, then we move further and continue up to get correct root of this algebraic equation. Solve x square plus x minus 3 is equal to 0 using Regula Falsi method. Here we have given algebraic equation in which we have given function of x which is on left hand side as x square plus x minus 3 as right hand side is here 0. So put it as a number 1. Now first we define the interval in which this algebraic equation has a root. For that we take the integer values of x. So take first as x0, we get function at 0 as equal to minus 3, as f of 0 not equal to 0, so x is equal to 0 is not of this root of algebraic equation, but the value of function at 0 is a negative. Now take second integer value as a 1, so we get function at 1 f of 1 as 1 square 1 plus 1 to 2 minus 3 is a minus 1. Now f of 1 is equal to minus 1, so x is equal to 1 is not a root of this algebraic equation, but function at 1 is having negative value. Now as a 0 and 1 both has a negative value of function, so root of this algebraic equation does not lie between these two integer value 0 and 1. Now we take next integer value as a 2. For f of 2 we get 2 square 4 plus 4, 6 minus 3 is a 3, as this is f of 2 is not equal 0, so x is equal to is not root of this algebraic equation, but function at 2 has a positive value. As you can observe, for 1 and 2 value of function changes its sign. For f of 1 it is a negative, for at f of 2 it is a positive. So 1 and 2 are two values in between the root of this algebraic equation lie. So we can define as root of this equation lie between interval 1 2. Now using this interval we can evaluate the solution or root of this algebraic equation. Now we have asked here by using Regula Falsi method. So first root in Regula, first approximate root in Regula Falsi denoted by x0, and x0 is given by a into f of b minus b into f of a divided by f of b minus f of a. Remember this formula, as here a is a 1 and b is a 2. Now so we take first endpoint 1 multiplied by value of function at second endpoint, that is f of 2, minus reverse the process. Now take second endpoint 2 multiplied by function at 1 as first endpoint, divided by take values of function is as they are in a numerator, that is f of 2, and take a subtraction and f of 1. Now putting the values, as 1 is multiplied here function at 2, we know function at 2 is here 3, so we put it in bracket, minus 2 into function at 1 has a value minus 1. In denominator we take 3 minus minus 1. Now simplifying this we get the value of x0 as 1.25. As you understand, this is the first approximate root. Now we have to check the value of function at f of at 1.25 to define whether it is a root or not. So function at 1.25, putting the value of x 1.25 in equation 1 on right hand side, we get 1.25 square plus 1.25 minus 3. By using calculator we get the value of f of 1.25 as a minus 0.1875. This states that the function at 1.25 not equal to 0, therefore x is equal to 125 is not a root of this algebraic equation. So we take next approximate root. Okay, we again repeat the process in a second iteration to find second approximate root. For simplification, as in first iteration, we take interval as 1 2 and find a value between 1 and 2 as a 1.25 as a approximate root. Okay, for 1 the value of function is a negative, so we take minus sign on top of the line, and for 2 function has a positive value. For 1.25 the function has a value minus 0.1875, that is negative. Now you can define the root, that is the root of this algebraic equation lie between 1.25 to 2, as the function change its sign to negative to positive, therefore we put as a x. So we can put this as a root lie between 1.25 to 2. Now using this interval we can find second approximate root. It is denoted by x1, so x1 is a lie between 1.25 to 2. Now using regular Falsi method, that means this formula, we for this interval we take x1 as a 1.25 into function at 2 minus 2 into function at 1.25 divided by function at 2 minus function at 1.25. Now put the values, as 1.25 is multiplied function at 2 is here 3, minus 2 is a multiplied function at 1.25 is a minus 0.1875 divided by 3 minus 0.1875. As using calculator we get the value of x1 as 1.294. So next approximate root is 1.294. Now we have to check f of the 1.294 is a root of the given algebraic equation by putting this value of x in equation 1. So on left hand side we get f of 1.294, on right hand side as 1.294 bracket square plus 1.294 minus 3. Now using calculator we have value of function at 1.294 is a minus 0.031. Now function at 1.294 not equal to 0. So 1.294 is not a root of this algebraic equation, as function at 1.294 is a negative value. So we using this approximate root we can define new interval for next approximate root. As to find this approximate root we use the interval as 1.25 to 2, and the approximate root by using this formula we calculate 1.294, which is in between this 1.25 to 1 to 2. For 1.25 the sign of function is negative, as it was minus 0.1875, and for 2 it is a positive, at f of 2 is a 3. For 1.294 the value of function is a minus 0.031, that is negative. Now you can observe as a sign of function changes negative to positive for 1.294 to 2. So root of equation lie between 1.294 to 2. Now using this interval we can find third approximate root, which is represented by x2. Now x2 lies between 1.294 to 2. So by using this formula, as first endpoint is 1.294 multiplied by function at 2 minus 2 is multiplied by function at 1.294 divided by, we take function at 2 minus function at 1.294. By putting the value as 1.294 multiplied by function at 2 is at 3, function at 2 is at 3 minus 2 is multiplied by function at 1.294 is a minus 0.031 divided by function at 2 3 minus 0.031. By using calculator we get the value of x2 as 1.3016, and this is the answer of this equation, as we carry only 3 iterations.